Hello! This will be a demonstration of Proposition 20 from Book 8 of Euclid's Elements, which says that if one mean proportional falls between two numbers, those numbers are similar plane numbers. Two things to say about this enunciation. One, I already gone through what exactly similar plane numbers are, why they're called plane numbers, why they're called similar. I did that in the video on Proposition 8.18. So if that's still kind of a foggy notion, it's a relatively new one, so it makes sense. Refer back to that previous video or simply ask me in the comments. Another thing to say about this enunciation is that when Euclid says if one mean proportional falls between two numbers, he's talking about one and only one. So not two mean proportionals, even though that would still mean that one mean proportional falls between them. He's talking about one and only one mean proportional. With that said, we're given two numbers, A and B, and there is one and only one mean proportional which falls between them. Call that C. So the number A is to the number C, just as the number C is to the number B. So that the number C is a mean proportional between A and B. And what we want to prove about the numbers A and B from this information is that they are similar plane numbers. We're going to begin this by creating the two numbers D and E. D and E will be the least numbers in the same ratio as A and C or C and B, since A has to C the same ratio that C has to B. We can, of course, do this by Proposition 733. One thing to note about this first step, this might not be necessary. It might be the case that AC and CB are already the least numbers in that ratio. But if that's the case, the proposition becomes a lot simpler, so Euclid doesn't go through that case. So, because D and E are the least numbers that have the same ratio as A and C and B, we constructed D and E in that way in our first step. We can then say by Proposition 720 that the least numbers of those which have the same ratio with them, they measure any numbers that have the same ratio with them the same number of times. The antecedent, and the consequent, That's Proposition 720. We've seen that several times by now. So that because D and E are the least numbers that have the same ratio as A and C and B, say by Proposition 720 that the number D measures the number A the same number of times that the number E measures the number C. And furthermore, that the number D measures the number C the same number of times that the number E measures the number B. With that information, we're going to create two more numbers, F and G. There will be as many units in F as there are D's in A. So the unit measures F the same number of times that D measures A. Or in other words, there are as many units in F as there are D's in A. And this is the same with E's in C. There are as many units in F as there are E's in C, because we know that D measures A the same number of times that E measures C. The number G shall be similarly constructed, but instead there will be as many units in G as there are D's in C, or as there are E's in B. Again, these are two ways of saying the same thing. Now, because there are as many units in the number F as there are D's in A, or in other words, that the unit measures F the same number of times that the number D measures the number A, we can then use the definition of multiplication, definition 715, to convert this into a statement about multiplication and say that the number D times the number F, or the product of D and F, is the number A. What this tells us is that the number A is a plane number, and D and F are its sides. In a similar way, we can prove that the number E times the number F makes the number C, that C is the product of E and F, and that the number E times the number G makes the number B, that the product of E and G is the number B, so that the number B as well is a plane number. So that's already half of what we wanted to prove. We wanted to prove that A and B are similar plane numbers, and we've just proved that they're plane numbers, so we just have to prove that they're similar. What that's going to look like is proving that their sides are proportional. The sides of A are D and F, and the sides of B are E and G. So we want to prove that D is to F just as E is to G. Here's how we're going to do that. We begin by noting that the number e has been multiplied by the two numbers f and g to make the two numbers c and b respectively. We said in step 5 that e times f makes c and e times g makes b. Again, this is a conversion of the statement about units in g. We're converting this into a statement about multiplication by definition 7.15, which just is the definition of multiplication. So that because e times f and g makes c and b respectively, we can then say by proposition 7.17 that the two numbers multiplied have the same ratio as the products. That is, that f is to g just as c is to b. But we know that c is to b just as d is to e. We made d and e in that way in our first step. So we have two ratios which are the same with the same ratio. Property of numbers tells us that they are the same with one another. So that d is to e just as f is to g. And we can of course alternate this proportion by proposition 7.13 and say that d is to f just as e is to g. And because this is the case, we can then say by the definition of similar plane numbers, which is definition 7.21, that because d is to f just as e is to g, the product of d and f is similar to the product of e and g. But we know the product of d and f is a, that was proven in step 4, and we know that the product of e and g is b, that was proven in step 5, so we can collapse this and say simply that the plane number a is similar to the plane number b, that the numbers a and b are similar plane numbers. And this is exactly what we set out to prove, which means we are done with the proposition, therefore, etc., q, e, d. I'm going to go over an example with particular numbers just to help make this sit a little bit better. This always helps me at least. We know that between the numbers 8 and 18, there is one mean proportional, namely 12. Because 8 is to 12, just as 12 is to 18. 12 is the one and only mean proportion that falls between 8 and 18. And what this proposition allows us to say is that 8 and 18 are what we would call similar plane numbers. What that's going to look like, again, is that if we make 8 and 18, we turn them into rectangles, those rectangles will be similar, that their sides will be proportional, and that their angles will be equal. So let's do that. That's going to look something like, we would turn 8 into 2 by 4. And then we would turn 18 into 3 by 6. Just like that. And of course, right angles. So we see that these two rectangles are proportional because 2 is to 4, just as 3 is to 6. Namely, that they're both as 1 is to 2, as the unit is to 2. And so this would be 8 because the product of 2 and 4 is 8. And this would be 18 because the product of 3 and 6 is 18. So we would say then that because these two rectangles are similar, that 8 and 18 are similar plane numbers. One final note to say about this proposition, this does not guarantee that if you take any two factors of 8 and any two factors or sides of 18, that you will necessarily get similar rectangles. Obviously, if I pick the sides 1 and 8, their product will obviously be 8. And if I take the sides 1 and 18, well, their product will obviously also be 18. But the rectangles, you can visualize that very easily. They obviously won't be similar. So there's no guarantee that if you pick any two sides, or as we would say, factors of 8, and you pick any two sides or factors of 18 and build a rectangle out of them, that those rectangles will necessarily be similar. But what this proposition does guarantee is that there will be a combination of two factors of 8 and two factors of 18 that, when making rectangles, will make similar rectangles, as we've just done right here. So 2, 4, 3, and 6, those make similar rectangles, and the products are 8 and 18. So we would still say 8 and 18 are similar plane numbers, even though not all of their factors can do this sort of thing. That's all I've got to say about this proposition, so I'll end the video here and move on to proposition 8.21.